Hey guys, welcome back. In this video I'm going to be talking about thermochemistry, thermodynamics. So basically, what is thermochemistry? Thermochemistry is the study of energy flow in a reaction. So to give you an example, when you have gas, when you have a hydrocarbon in an engine, okay, your car uses gas, it ignites it, and it produces energy. It releases energy. Okay. In the case of a hydrocarbon, it's a really enormous amount of energy compared to other reactions. So that's why they use gas. But anyways, that energy can be used in two different forms. It can be used to do work, and it can be used to produce heat. Okay. And so the definitions of those are quite important. Work is what you need to move an object with matter a certain distance, okay? An object with mass, okay? A certain distance. And then heat is what is needed to raise the temperature of an object. That's simple enough. And one thing I wanted to give you some intuition about was some of the equations that you will find in the book, okay? And they get a little complicated, and there are quite a lot of them. But if you think about them, then they're not really that hard to remember. Okay? So, for example, work is equal to force times the distance. Okay? Which makes sense. Okay? Because work, if you remember your definition, is what is needed, okay, the energy that is needed to move matter with mass a certain distance, okay? So the amount of force that you need, okay? So this accounts for how heavy it is, pretty much, okay? And then the distance accounts for how far you are moving it, okay? So which it makes perfect sense. If the object is heavier, you need more force, okay? Meaning you're doing more work. If the object, you need to move the object further, then the distance is greater, which will equal to greater work. All right. So just if you think about it in a logical way, then the formulas are not too hard. Now, one more thing I wanted to talk about was kinetic energy and potential energy. I'll start with potential. Potential energy is just the energy that an object has relative to its position, okay, which is quite easy to remember because of position, potential. Now, let's say this is our reference point, the ground, okay? An object up here, I don't know, let's draw a ball. An object up here will have a higher potential energy. Let's just say it's sitting up there. Higher potential energy, okay, than a ball down here. Alright? So think about it like this. Another concept I can introduce right now that is related to this is the conservation of energy. Energy is never created nor destroyed, but it is transformed. Okay? And I will show you that. Let's say at the ground, its energy is equal to 0. Alright? And we're going to move the ball up. Okay, we pick up the ball and we're doing work, meaning we're using energy. Okay, and we're burning the energy. Where's that energy going? If the energy is conserved, it has to go somewhere, right? Some of it is lost through heat. Your body will give out some heat as you do work. You're not going to notice it very much, but imagine that you're playing a sport or you're doing some really hard work. You will sweat, and then you will feel the release of heat. Alright? So some of the energy will be released as heat, and some of the energy will be used to do the work. And as you move the ball up and you do the work, then the energy that is work will be transferred into the ball. Okay? And that ball, as it rises up, you do more work, more energy is going into the ball until you finally place it at the top. Okay? And now that ball is resting here. And due to its position, okay, the amount of work that was needed to get it up there, that is now transferred into the ball, will have a higher, more energy. Okay, let's call it 10. Alright, and I guess another thing I can introduce is just a unit of energy. It's the joule. It's just one of the units that you can use for energy. It's called joule. And that's basically it for that. And now, the energy of movement, of motion.